Never forget to stay hydrated. That's why I have my water over here. Alright, today we're going to be doing Advent of Code Day 16. Every day, there's 2 program puzzles released as part of the month-long challenge called Advent of Code, and this goes until Christmas. So I'm going to be doing every single one of these challenges and making video solutions. So if you want to check out all the other ones, they're in a playlist, which is linked to in the description. Additionally, I also have my code in a GitHub repository, which is also linked in the description. So if you want to check out my code, you can go find it in the description. Also, according to YouTube statistics, only 11% of you are subscribed who are watching the video. So please consider subscribing. Helps a lot. Please show your support if you enjoy this content. It takes a lot of effort to make these videos every day. And I'm going to continue making programming content after this is all over. So today we're just going to be doing Day 16 of Advent of Code. Alright, Day 16, Ticket Translation. As you're walking to yet another connecting flight, you realize that one of the legs of your rerouted trip coming up is on a high-speed train. However, the train ticket you were given is in a language you don't understand. You should probably figure out what it says before you get to the train station after the next flight. Unfortunately, you can't actually read the words on a ticket. However, you can, read the numbers, and so you figure out the fields these tickets must have and the valid ranges for values in those fields. You collect the rules for ticket fields, the numbers on your ticket, and the numbers on other nearby tickets for the same train service via the airport security cameras, together into a single document you can reference, your puzzle input. Okay, that's a little bit sketchy, but that's okay. The rules for ticket fields specify a list of fields that exist somewhere on the ticket and the valid ranges of values for each field. For example, a rule like class 1 to 3 or 5 to 7 means that one of the fields in every ticket is named class and can be any value in the ranges 1 to 3 or 5 to 7 inclusive. Each ticket is represented by a single line of comma-separated values. The values are the numbers on the ticket in the order they appear. Every ticket has the same format. For example, consider this ticket. So give an example. Here, a question mark represents text in a language you don't understand. This ticket might be represented as 1 to 3, 1 to 2, 1 to 3, so on. Of course, the actual train tickets you're looking at are much more complicated. In any case, you've extracted just the numbers in such a way that the first number is always in the same specified field, the second number is always a different specified field, and so on. You just don't know what each position actually means. So basically, we just have a number of tickets, and each ticket is formatted the same, and we don't know which positions correspond to which values, but it's always ordered the same. So it might as well just be a list of values and fields. Okay, start by determining which tickets are completely invalid. These are tickets that contain values which aren't valid for any field. Ignore your ticket for now. Sorry. It doesn't matter which position corresponds to which field. You can identify invalid nearby tickets by considering only whether tickets contain values that are not valid for any field. In this example, the values on the first nearby ticket are all valid for at least one field. This is not true of the other 3 nearby tickets. The values 4, 55, and 12 are not valid for any field. Adding together all the invalid values produces your ticket scanning error rate, 71. So we have to find our ticket scanning error rates. Alright, so let's just grab the puzzle input, and after 5 seconds, I will be back to explain the solution. Okay, so we have arrived at our first answer, and this is 18227. So hopefully that's right. Alright, that's the right answer. Okay, now it's time to explain. So basically, we're just given a list of nearby tickets, and for each nearby ticket, there's a list of the values of each field, but we don't know which fields are which. So we need to look at each of the ranges, and each range describes a valid, like possible values for each field. So we just need to go through each field, determine which values are valid, and then compile a list of valid values. And if you look at the input, you'll notice that each of these is only 2 ranges combined. So you only need to look at like these 2 ranges. So there's not like 3, there's not 1, there's always 2. So that's pretty important to note. So at the beginning, we just want to get all these ranges, and I guess I could print these out for you. So for R in ranges, print R. I guess I'll just show you what these look like and what we're aiming for. So this might be a little bit difficult to read because this text is so small, and I should try to make it larger. But basically what we have is a list of lists, and each list inside the big one is going to be two elements, and each element describes a range, and each range is described by just a lower bound and an upper bound. So you have two ranges inside every element of this list, and this is how we're basically storing it. Okay, now I'm going to explain how we actually parse the input to get these ranges. So we have this list just to store the ranges. It's just a variable to initialize it. Then we loop from the beginning until it hits a new line. And when it hits a new line, that's going to be an empty element in our data list, because our data list is basically just all the lines put into a list. So we want to loop while we don't hit an empty line. So while we don't hit an empty line, that's all the stuff over here. We consider every line individually. So let's consider this one, for example. First, we want to find the index of the colon. So data index, this is basically just the current line, because we're referencing an element inside our data list. And this is just a singular line. So data index is just a singular line. We find the index of the colon. We add 2. So we go 1, 2. So now we're at the first character. So we only want to consider everything that's after the colon, after the space. So now we're just left with all of this. And that's basically what's described over here. We're just taking a substring. After that, we split it by spaces just to get each of the individual parts. So we get first range, or, and then second range. For the first range, we just have to convert everything into an integer after splitting it at the, I guess, dash? It's not really a dash. It's a hyphen or something. I don't know. Some sort of dash thingy. We split it by that, and then we convert each of the parts into an integer. So the lower part becomes an integer, and the upper part becomes an integer, because they're actually strings. So we have to, cast them to integers. After that, we have our two ranges, and then we just append that to our ranges list. After that, that's what we get over here. That's what I showed you in the terminal, I guess. All right, now after that, we need to find all nearby tickets. So we look at the nearby tickets, and we see this is pretty simple. But how do we determine which line that's on, right? So we have to keep looping until we hit a line that says nearby tickets. So now we're at this line. Then we increment by 1 to get to the first. Here, I guess I should put a comma over here. All right, so now we have lines that contain nearby tickets, and then we increment by 1 to get to the actual nearby tickets line. So that's all the stuff over here. So now we're at this first line, and then for each of those, we just split it by commas, and then convert all of those to integers. And basically, the syntax I'm using here for creating an integer list out of a string, this is called list comprehension, and it's pretty useful to know if you're going to be doing advent of code. It's pretty helpful, I think. You just want to convert everything to integers, and you want a list, and you want to do it really concisely, then you should use list comprehension. And I will make sure to put a link describing that in the description. I've been actually using this for a lot of previous days, so maybe I should have done this sooner. I don't know. But list comprehension, pretty useful. So we have our ticket, which just composes of the integers in the list. After that, we just append that to our list of nearby tickets. And then we just keep looping through the data while it's still there. So now we have our list of nearby tickets and our ranges as well. So we have everything we need. We've parsed our input successfully. That was all just parsing input. And now we have our actual function, which determines if a ticket is valid. Actually determines the scanning error rate, which basically sums all the invalid values. So let's just look at this for now. So we have our ticket, and we have our valid ranges. First, we want to sum. So we initialize a variable which contains our sum. And then we loop through every value in the ticket, and we want to see if that value is valid, basically. We want to see if it exists in some ranges of some valid values for some field in there. So we consider every single field in there, and then for every field we have a list of valid ranges, right? So we just take a look at those, and remember, each field in the list, each valid value for every field in the list is described as two ranges. So we decompress those two ranges, and if you don't know this technique, it's basically if you have a list of lists or a list of tuples, you can always extrapolate those into like variables when you're looping through the range. Looping through the list. So that's a useful technique to know. We extrapolate those into range 1 and range 2. These are just the possible ranges that can exist for that field. And then after that, we want to look at the first range. We want to see if the lower bound and the upper bound contain value, and the lower bound and upper bound of the second range contain the value on the ticket. If one of these does, then it's valid for that field. So we know that it's valid for the entire ticket. And if it's not valid, if we haven't verified that the value on the ticket is like valid for some field on the ticket, then the error rate, we need to add our value to the error rate. And at the end, we just return the error rate. And then we basically just have a total error rate for all nearby tickets. And we go through all nearby tickets and find the error rates for those. And we print it out at the end. All right, that was pretty simple. We can go to part 2. All right, part 2. Now that you've identified which tickets contain invalid values, discard those tickets entirely. Use the remaining valid tickets to determine which field is which. Using the valid ranges for each field, determine what order the fields appear on the tickets. The order is consistent between all tickets. If your C is the third field, it is the third field on every ticket, including your ticket. For example, suppose you have the following notes. All right. Based on nearby tickets in the above example, the first position must be row, the second position must be class, and the third position must be seat. You can conclude that in your ticket, class is 12, row is 11, and C is 3. Once you work out which field is which, look for the 6 fields on your ticket that start with the word departure. What do you get if you multiply those 6 values together? Oh, all right. So there's actually quite a lot of departure fields, and there's exactly 6, so that's good. This is looking a little bit complicated, but I'm sure it'll be fine. I actually don't know how to solve this immediately because there's too many values to do a permutation. Why don't we actually just find the permutation? Sorry, I meant finding the total length of a ticket. How many fields are in there? Okay, looks like there's 20. 20 is quite a lot. I don't think we can do a bash on that. So we'll have to figure it out, and I'll see you in 5 seconds. All right, that took a lot of work, but we got our answer. And it's gonna be a pain to explain. No, it's not the right answer. Oh my god. Why? Oh, okay, never mind. Let's do this again. Actually, no, let's just do it right now. Wait, yes? Oh, no, okay. No, let's go back to just... Yep, okay, we got our answer. It's a lot bigger, which should make sense. Woohoo! Okay, I think today this was probably the most difficult part 2. Yeah, out of all previous days. So I guess I should explain. I'm gonna assume this was difficult for maybe a lot of you too. Maybe not difficult, but just like lots of implementation. You can see my code is like 100 or so lines long. So let's just get to explaining. So first I'm going to explain the high level strategy, and then I'll go into the code. Actually, I might not go into the code that much because it's a little bit complicated. I don't want to explain every line. So I'll just explain maybe the general stuff. So in general, our strategy is going to be to look at all possible positions in the ticket. So this is like 0, 1, 2, all the way to 20. These are the possible positions. We want to determine which field could correspond to each position. And this is like position 0, 1, 2, 3, so on. So for example, in this example, we want to look at position 0, and we see that position 0 has to be row. position 0 has to be row. And then we look at position 1, and then we see that position 1 has to be class. And then we look at position 2, and position 2 has to be seat. And we're doing this 0 index, by the way. So how we do this is, first we need to compile a list of all the tickets just to help us do this. And all tickets contains our ticket as well. So we just get a list of all the tickets, and this is the same as in part 1. We just have each ticket is just a list of integers of length 20 in our case. I'm not sure what the inputs are for other people, but the length of each ticket in this case is 20. So after that, we have our same scanning error rate thing just to determine if a ticket is valid, because we want to throw out all the invalid tickets. Scanning error rate still has the same implementation. It still returns an integer, which is the scanning error rate. We just remove all the ones that are like 0. We just remove all the invalid tickets. Sorry, we remove all the ones that have an error rate greater than 0, because that means it gets invalid. After that, we want to determine the possible ranges for each position, because each position could potentially correspond to more than one, say, field, right? Because first position could actually be, for example, arrival platform and arrival track if it fits both those ranges for every single ticket. But we have a strategy for that, which I'll explain later. So we go through, so we have a possible ranges. This is just storing which field is possible for every position in the ticket. So we go through every position, and this is from 0 to 20. This is every position in the ticket, that is. And we're considering this for all tickets. We want to find out which fields work. So to find this out, we go through all possible fields, and I should actually rename ranges to perhaps field ranges to make it more clear. So let's just do that. Field ranges instead of ranges. Hang on. Okay, so now let's replace this a little bit more clear now. So we want to go through every single field, and each field has a range, right? So we look at the ranges. There are two possible ranges, as we stated in part 1. The first range, they're just ranges, okay? Now we want to go through every ticket to find out if this range is a possibility, because we're just brute forcing this. We're seeing if a certain range works, and if it does, then we want to add it to our list of fields that actually work. And to find out if a field works, again, we go through all the tickets, and then we find out if it works for every ticket. If it fails for even one ticket, that ticket is still valid, so it doesn't fit at all. So that field is totally invalid. That's what this line does. So if it's valid, if it fits every single one of those tickets, if the field fits every single one of the tickets for our given position, field index, then it works. Then we basically add our possible field ranges. We add our fields that work at the end to our possible field ranges. And fields that work is basically just the indexes of the fields. So it starts from 0. So for example, departure location will be 0, departure station will be 2, 1, departure platform will be 2, and so on. We just add those integers to fields that work, and fields that work is specific to every position. So every position, we now know which fields work. And to actually aid in this explanation, I will print this out for for PFR in POS. Print PFR. And when I did that replace it, actually didn't work. Okay. Anyway, we see that for position 0, and this is all the ones on the tickets over here. So this would be 680, 876, 869, 244, 626, and so on. That could be either field 10 or 11. So that would correspond to arrival platform and arrival track. And then we see for field 1, this is the position 1. This is all 418, 910, so on. That has actually a lot of possible fields that work for it, and so on, so on, so on. So we might think, oh no, this is impossible, right? We need to narrow this down to one possibility for each position. And this is actually, we notice something about the input that makes this a lot easier, which is that we see that it starts with one position that only has one possible field. And this is somewhere down the line. I don't know what position it is, but it's field 11. So one of these positions only has one possibility, and that's field 11. After that, we can eliminate 11 from all the other possible fields because fields are not duplicated. So we know that each position only corresponds to each field only corresponds to one position. So we can remove that field from all the other possible fields for every position. And we do this through process of elimination. So we have our final range. This is for every position, we want to find our final answer, which is the only field that is possible for that position. We go through all of those, and then after that, we want to we want to do this 20 times because we're going to find unique fields 20 times for each position in our list of possible fields for each position. For each of those, we have a possible fields. And then if the length of possible fields is only 1, that means there's only one possible field for that position. And that means we can actually just set that to our final answer. So our final answer for that position, which only has one possible field, is just going to be that possible field. And yeah, basically in this example, we'd loop through, we'd see that this position only has one possible field, which is 11. So we know that that position has to correspond to field 11. After that, we want to remove, for example, 11 from all the other possible fields for each position. So we go through all of the other positions and we remove, sorry, this was just for debugging. We just remove that field that we determined already corresponded to a particular position. We remove that from all of the other possible positions, possible fields. So yeah, after that we just get a unique list, and I'm just going to print that out. This is print final range, and it gives us this. So this is our final line. It tells us that field 0, position 0 corresponds to field 10, position 1 corresponds to field 17, position 2 corresponds to field 13, and so on. And after that, we just need to find out which positions in the tickets correspond to the first 6 fields. And we can do that by checking that the field corresponding to that position is less than 6, because I'm assuming that for everyone's input, the first 6 fields are the departure ones, which we need to multiply together. So we find the ones that correspond to the first 6 fields. We find those positions, we multiply the values of those, we multiply our ticket values at those positions together, and then we get our answer. So yeah, that was a little bit confusing, perhaps. As always, leave feedback for me if for improvement and stuff. It's always helpful. I want to make these videos more clear, so feel free to leave comments for feedback. Additionally, you can always DM me on Discord. My username and tag is in the description, so you can check that out. But yeah, that's basically it for day 16. Might have been a bit confusing. You can also check the subreddit for other people's solutions, but my solution is in this video, and you can check out the code in the GitHub repository, which is linked in the description. In fact, I'll just push this to GitHub right now. All right, so now we're done. We pushed it to GitHub. You can check that out. I don't actually know. Oh, untracked. Okay, that's fine. That's fine. I don't care if it's untracked. But that's it for this video. Yeah, this has been fun. We still have a few more days left. It's almost basically Christmas. Almost. There's 9 days left, which is pretty surprising. So we're going to be traveling somewhere, and eventually we'll end up at our vacation island. So thanks for watching. Please consider subscribing. We're trying to hit 400 by the end of the year. And that's it for today's video. So thanks, and I'll see you tomorrow at day 17. Goodbye.